So, welcome to the EMEA version of the vBrownBags. Today we have Michael Gasch, William Lamb, and PK. I'm sorry, I'm not going to butcher your name. With the topic of unlocking the potential of events for SDDC automation. This mainly will resolve around the VEBA appliance, I'm told.
Yep.
And perfect. And just to get the usual housekeeping out of the way, we do have them in EMEA on a semi-regular basis. If we have them, the show runs Tuesday, 7 p.m. London time or 8 p.m. Central European time. If you do want to present, we will be running a CNA series in the next couple of weeks. So get in touch with the Twitter hashtag vBrownBag, or with any of the EMEA hosts. That would be myself, Greg Robertson, or Dan Belmonte. And with that, I'd say we have our speakers introduce themselves. I'd say in the order they're gonna speak, so that would make you go first, PK.
All right, hey guys, I'm PK. My name is Parthiban Kandasamy. I go by PK, and I'm the PM for VEBA.
Then William, I believe.
Hey guys, this is William Lamb. I work on the VMware cloud team.
And Michael.
Hey, I'm Michael. I work in VMware Office of the CTO, staff engineer, and working on VEBA.
Okay, perfect. And then I think we can kick things off, PK.
All right, awesome. I just want to make sure that you're seeing the right screen.
Yes, we are. Also, if you do have any questions, you can either use the chat and post them to the panelists, or use the Q&A button.
Awesome, and we'll save some time for questions towards the end as well. All right, awesome. So yeah, thanks for first of all giving us the opportunity to talk about VMware event-broker-appliance and how we can help unlock the power of events for SDDC automation. And as we introduced ourselves, I'm PK, and William Lamb and Michael Gasch will be doing some cool stuff with the demo and showcasing the product. We can be reached at dl-veba@vmware.com, and I'll show you guys more ways to get in touch with us towards the end of the presentation. For this talk, we're gonna cover events and what that means, what that looks like with vCenter, and I'm gonna introduce the event broker appliance and showcase how we can get to an event-driven automation state. We'll cover some use cases as well as take a look at the architecture for VEBA. And then I'm going to introduce the functions as it relates to VEBA and show you guys some pre-built functions that we've made available, and also covers the execution flow, sort of a deep dive on how functions work under the covers. And then we'll do a release update with some of the major enhancements that were provided with 0.3 and what that means for you guys. And then Michael and William will take over to do a demo, and we'll save some time for the questions at the end. And hopefully by the time I'm done with the presentation, I get you guys excited about event-driven automation and how VEBA can help provide that to you easily, and get you guys excited about deploying VEBA in your SDDC and give us feedback about how we can improve the product further. So jumping right in. Yeah, so let's take a look at events. And so with any system today, users typically interact with system using some sort of a command driven model. Right, and most of these commands tend to induce some sort of a state change to an entity, and systems produce these events to kind of log these state changes, and they kind of capture who made the change, what the change was, and when the change happened, right? And these are produced for a number of reasons, from auditing to troubleshooting to analysis at a later point. and different systems have different ways of representing these events. And if we take vCenter as an example, there are over 1,600 unique events with the version 6.7. And let's dive into vCenter events real quick. vCenter publishes a lot of useful events. Pretty much any action that you do on vCenter translates to an event that you can see in the UI. If we were to, and all of the events are documented under the vSphere API reference guide. But if we were to understand how the events are structured, we can look at it top down just to understand the hierarchy. And we'll start with the event object itself, and we can see how it's categorized by different objects that can be impacted. Like, for example, a data center event, or a host event, or a VM event. And if we were to look at a VM event, we see it's further subdivided into by different actions that can be performed on an event on a VM. And let's take a look at a VM powered on event. And we see that it's further categorized by a DRS VM powered on event or a HA VM restarted event, right? So hopefully this gives you a hierarchical overview of how events are structured and gives you that context. Alternatively, you can also use PowerCLI or any vSphere SDK to interact with events. And William Lamb has a blog post out there talking about events and how you can find all the events by connecting to your vCenter, and has made a complete export of events available in his GitHub repository. Now let's see how we can talk about the core of what we're here to do, which is event-driven automation, right? And before I talk about the VEBA appliance itself, I wanted to show how you can trigger actions based on vCenter events today using alarms, which provides the ability to send email or send SNMP traps or run commands, and that's triggered by an event within vCenter. However, this limits innovation to an extent because, one, you need vCenter UI access, right, to set up these alarms. And if you choose to run commands or run scripts, there is probably a significant learning curve, and you need to abide by some guidelines, and also there's this probably a need to write redundant connectivity or platform code. And additionally, this would be an additional overhead on vCenter because all of this is contained within vCenter, right? Now, this is where VEBA can come in, right? And by owning the event routing and the processing off of vCenter, it allows that seamless extension of vCenter platform. VEBA is deployed as an appliance, and it enables innovation without requiring vCenter UI access. And it can also enable a fan-out messaging pattern. And what I mean by that is when an event happens, you can concurrently have multiple actions take place. For example, let's say a VM gets powered off, you can have a tag applied, you can store that event in a database, you can immediately Slack, and all that happens concurrently, like you can kick off those actions at the same time. And VEBA provides a function as a service platform, right? And so it enables you to write and execute code written in any language. And so what that means to you is if you have a script written in PowerCLI, you can easily convert that to a function that can be then triggered through an event. And let's say you don't have the time, you can go find an intern that's able to write code, give them the requirements, and have them write the function for you and have that deployed in VEBA. VEBA makes it really easy to do this event-driven automation. And alternatively, to get started quickly, we also make available some pre-built functions that's maintained by the community and available in our GitHub repository.
Hey, PK.
Yep.
Can I just make a quick comment on the previous one?
Yep, sure.
Cool. Because you brought up an important. Oh, can you go back? Okay, thanks. You're making an important point here, saying that you don't need access. Like, you basically decouple the consumer your business unit or whatever from vCenter access. That means you shield vCenter not just from resource perspectives, like the more connections, obviously the more resources are going to be used on vCenter, but also from a security perspective. Just because your consumers are interested in certain events, they don't necessarily need a service account or direct vCenter access, which as of today, we usually see when you write scripts against vCenter. So this is a resource and security a benefit and advantage that this decoupling through VEBA brings for our customers and communities.
Yeah, and that funneling allows you to really be very granular on what events you're interested in and what channel you want to send them in. And so to Michael's point, right, if you have very specific auditing requirements, you can send the auditing specific events to your security folks, and everybody else who does not need to see that information, they don't see that. Today, you're kind of exposing that information indirectly by providing direct to vCenter access. And so this is really critical for some of those cases where you want to basically have some separation of duties. The last thing I will mention here is that, VEBA is packaged together as an appliance, mainly from a ease of consumption for a lot of folks. But underneath the hood, and I think PK will go into this, it's actually running as a modern Kubernetes application. That level of detail you guys don't really need to know about, but you can literally deploy VEBA if you have a highly available Kubernetes cluster, and you can actually make VEBA highly available when you deploy that stack. And in fact, we have some deployments of this running on Project Pacific already on vSphere 7.0 or any other upstream Kubernetes infrastructure as well. So the appliance is merely one form factor of it, but the underlying mechanism can be deployed in a number of different ways.
Yep. Yeah, good pointers. So let's see. All right, so let me kind of show you guys like what actually is comprised of the VEBA appliance itself. Now, VEBA is a VMware Fling project, and again, we aim, like Michael and William pointed out, we aim to expose new capabilities and extend the vCenter platform to different channels and new capabilities, right? And all of this through an event-driven approach. And like William pointed out, we're built on cloud-native technologies, but all that is abstracted away. There's Kubernetes and containers and FAS that powers VEBA, but you get to see the appliance. And if you're interested, you can deploy VEBA in your own Kubernetes cluster. Now, we're completely open source and community driven. All of our source code and examples are made available in our GitHub repository and out there for you to use and contribute. We're designed to support multiple providers and processors. Sorry, was there a question?
More of a general comment, I think, at this stage. How would you, so I have a support background, right? And I've seen support tickets come in for Flings, which is not the correct way to file support tickets for a Fling, because Flings are not officially supported products, right? What's for VEBA, what's your preferred way of issue reporting then? Just GitHub issues?
Yeah, there's two kind of, I'll just jump in there real quick. There's kind of two mechanisms you can interact with from a Flings project standpoint. The Fling website has the ability for folks to basically comment and just run into just general questions or issues. So there's that aspect of it. There's also the ability to basically file quote unquote a bug. So if you think you found some issues or something's not happening correctly, you can certainly use the Flings website. They kind of provide that natively. Because this particular Fling is an open source project, all of this code is actually on GitHub. So ideally, we'd like folks to interact with us via the GitHub repo. You can file issues. In fact, you can contribute. We've had a number of folks actually contribute code, samples, and all that. So in either of those scenarios are perfectly fine. But GitHub is actually where we do all of our development. And so if you want to interact with us in a native platform, GitHub is certainly there. Or if you're more comfortable with using the Flings website, we monitor both pages, basically.
Perfect. Thank you.
Yeah, and the team's very responsive as well. So yeah, either ways, reach out and we'll provide the guidance that you need. All right, so like I said, we're designed to sort of extend support to multiple providers and processors. Today we have vCenter providing the event, acting as the event provider. And today we have over 250 downloads of VEBA since it was launched originally at VMware 2019. Just as a quick show of stats. And diving into the use cases a little bit. Now, some other common use cases where we see VEBA applied or this typical monitoring, alerting, or notification. But now you can kind of watch for the health or availability or capacity, primarily from an event-driven perspective, right? And you can watch for events that lead up to an impacting issue and automatically notify through a channel of your choice, not just email, but use any text message, Slack, or PagerDuty, any interface that any application that has an API. And then you can take that a step further. You can respond to those alerts and do automated remediation, right? For example, if you have capacity shortfalls, you can reclaim those capacity or rebalance workloads or allocate new capacity blocks. Now, if you need some sort of a manual intervention, you can automatically, in response to an event, you can create tickets, hand it off to different stakeholders, and have them review the change, right? And like William said, auditing, if most companies already have some sort of a CM tool, but they're inundated with a lot of these events, right? But if you are interested in a subset of events, you can absolutely just watch for those using VEBA and filter out all the noise. Now, some of the other possibilities are you can absolutely go ahead and build intricate workflows through chaining functions. You can have one function call another function, sort of build this if this then that type of logic. And another possibility is storing these events into some sort of a database or sending them to Kafka for further processing or batching. And from there on, you can build your own dashboards, and you can take it a step further and have machine learning, right? Have this data train your algorithms and then use that to predict anomalies in your vCenter workloads. Now, jumping into the appliance, I wanted to quickly show you guys what makes VEBA possible, right? VEBA, the appliance is powered by the Photon OS, and there's a single node Kubernetes cluster, and we have Contour providing the ingress controller, providing the plumbing to get to the different endpoints that we expose. And with this core platform, we now have the ability to put together the eventing platform, right? If we take a look at the event router, which is the heart of VEBA, there are two containers. One is the tiny www server that serves the different endpoints that you'll interact with. And then there's the VMware event router, which processes the events and invokes different processors. Now, once we have this in place, we're now able to hook up to vCenter as the event provider and stream all the events from vCenter. Now, the event router then processes these events and then invokes the processor. Now, with VEBA, we have an inbuilt processor with OpenFaaS. And once OpenFaaS component is available, we then make a function where we then give you a function as a service platform, which enables you to write and deploy functions or code in any language of your choice. Right? For customers that are on VMC or looking to do more with native AWS capabilities, we absolutely have a way for you to hook up to AWS Event Bridge as the processor, and from there on, you can take advantage of CloudWatch or Lambda and do more there, right? And as you can see, we completely have an open source, a sort of open ecosystem, and we want to enable sort of the event-driven automation in an open manner. And once you have the appliance deployed, we make available certain HTTP endpoints, right? So if you go to the fqdn/stats, you get access to the telemetry data on processed events. And there's a bootstrap endpoint, where you can see the logs from the first time we bootstrap the appliance with all the components. And then there's a status endpoint where you can check the appliance status. And for customers with OpenFaaS, there's a UI endpoint where you can go interact with the OpenFaaS GUI. Now with that, let me talk about functions and what they mean, and show you guys some of the examples that we have. So in my mind, functions in the context of VEBA are triggered on demand and are a unit of execution of code, right? Like code that's self-contained and does one thing and one thing really well, right? And what I have here are some example or pre-built functions that we made available. It's well documented in our GitHub repository, and we have some documentation out there to show you how to deploy these functions as well. Now, I wanted to show you guys the stack.yaml, which is the key descriptor that tells VEBA how to handle your function, how to handle your code, right? And if we start from the top, we need to know who the processor is, right, with OpenFaaS, and the gateway essentially is the VEBA endpoint. So once you have VEBA deployed, you'll provide the VEBA FQDN as the gateway, and you'll specify the language that you're using to write your function. And the handler is basically the location of the scripts, and you'll provide the image that you're using to build your function. And for those that need some environment variables available to you within your function, you can use the environment tag and pass those on. And then there's also an option to load configs. So if you have some credentials or sensitive information that you want to pass onto your function and make it available there, you can absolutely use the secrets and pass it on as a file. And I'll show you how that gets made available within your function in the next slide. And this function, obviously, we need it to be triggered on an event, and that's shown here. That's mentioned under the annotations topic, and I want this function to be triggered on with a DRS VM powered on event. So this is a key descriptor that tells VEBA how the function needs to be handled and executed. Now, I wanted to now show you guys how the function execution works in itself. Now, at a high level, the VMware event-broker-appliance is a sort of a black box. It enables you to talk to vCenter, get all the events, and has some functions running that is able to talk to external third-party systems, right? Now, if we peel back the layer, we'll see that VMware, the event router, is the key component that hooks up to vCenter. And once it receives an event, it translates that into a cloud event. And it's basically encapsulating it so the functions can have a uniform and a structured, standardized way of getting these events. And this gets passed on to OpenFaaS through a HTTP request argument. And OpenFaaS then converts this into a standard input and invokes your function. Now let's take a look at what your typical function would look like. I'm here showing a PowerCLI calling a Slack API. So within your function itself, like I said, if you have a config that you've made available, that's located under the folder var OpenFaaS secrets. You can read that and get the config that you want. And the actual event itself is made available under the standard input argument, right? So in PowerShell or PowerCLI, it's the args variable, and you can read that, convert that to JSON, and then get the data that you want out of the event. Now, in this example, I'm using, I want to invoke Slack, so I'm just invoking, importing the Slack module, and creating a message is just a couple of lines code. And once you have that, when the event happens, the function executes and it's able to post a message to Slack. I want to show you guys how different this is in a Python if you were to write a Python code. So all that's different in a Python code is the event object is now made available to Python under a request object, right? And under a request argument. And you can read that, convert that to JSON, and if you implement your business logic from there on, you can you can extend vCenter to any third-party application, ones that have API, that is, right? You can see how easily and we can make event-driven automation and how easy it is to implement through VEBA. I want to show you guys some.
PK, I have one question on that. What's the delay between the event happening on vCenter and the event router actually picking it up? Is it immediate? Is it a couple of seconds? Is it a couple of minutes?
It's definitely in the seconds range, immediate to seconds range. And also it might depend on what you're doing within your function itself, right? If your function
no, I'm not talking about the delay that the function needs to run. It's really, if you look at stuff like VROPS, right, which can also take vCenter alarms, for example. VROPS runs on a 5-minute cycle. So worst case, you have a 10-minute delay for VROPS to pick anything up. Same for login site. Login site runs on cascading 5-minute schedules to run queries, right? If you want to automate things for event-based monitoring, especially. So this the event router picks up vCenter events within a couple of seconds. Then.
Yep, but it's very immediate.
Okay, cool. Thank you.
Yep. All right. And I wanted to talk about some release updates. The teams worked a lot with the latest release and made some significant improvements. Even though it's a dot release, it's a significant change. So I want to spend some time talking about it. So with 0.3, we now support multiple events per function. So previously we just had support for one event that can trigger a function. Now a function can be triggered through multiple events. And we've made a breaking change, but this sets us up for a better future, right? We're conforming to cloud events, which provides a standard way of exposing the events. And we're designed to now kind of allow different stream providers and processors so we can go beyond just vCenter and OpenFaaS. Now with 0.3, we've included the support for AWS Event Bridge as the stream processor. And you can see we've implemented with kind of the future extensibility in mind. And we now also support all vCenter events, including the extended events that are available. And we have also made available the new stats endpoint that provides access to the telemetry data with 0.3. So with that, I'm going to transition it off to William and Michael to show you guys the product live and showcase some of the capabilities that it has.
And also just a quick reminder again, if you have any questions, feel free, use the chat, use the Q&A. Actually, yeah.
Are you guys able to see my screen okay?
Yeah.
Yes.
Okay, cool. So I kind of just started off the deployment, but just so you can see, like, hopefully in this demo, you'll have to be able to see how easy it is to basically take an event in vCenter, or historically you have to write all that code, right? And sometimes in a particular language, right? Because maybe that particular SDK is easier to use. And the idea here is we want to make that super simple. And that stack.yaml file, I'll show you in a second, it's literally pasting in the specific event that you want. And that's all you have to do. There's no additional code that you need to think about. And the beauty of something like VEBA is that we allow you to really focus on what we normally refer to as the business logic, or the thing that you actually want to do. Whether that's sending a message to Slack, sending that a text message. I mean, you can even send a physical letter. There's a bunch of services out there that have APIs for that, right? So the idea is that you get to really write just the minimum amount of code to do the thing that you're interested in, and everything else that gets the event from vCenter, processes it, all that information is all done for you automatically, and that's part of the VEBA offering. And so just before I get started, there was a repo that was mentioned by PK. So by default in 6.7U3, we have about 600 events. If you look at VMC M9 right now, or the M10 release, there's over like 1,900 events. So there's even more coming, right? There's a script that I put out there that you can actually generate this, because every single environment is actually slightly different. Out of the box, there are a certain amount of events that vCenter has, but as you add new solutions, whether it's second or third party, like backups, for example, or monitoring, they might actually inject their own custom events. vCenter is very extensible from that standpoint. So you might have 1,600 out of the box, and maybe if you look at one particular environment, you might have more. So there's a script out there that you can run that generates this, and you can actually quickly search through the event name, right, what you're interested in. Maybe there's a description. So this is how you basically figure out what kind of event that you're interested in. So no longer do you have to really play around with the APIs. You can just come here and just start searching. So this is something that's available for you guys. Fling is available here, downloaded via the Fling's website. This is where the OVA is available. And then if you're interested in the actual source code, you can go to the GitHub repo. Here I've got this VMware Cloud and AWS infrastructure set up, and we're going to go through this environment. So standard import of the OVA. There's a couple of pieces of information that you'll need. Obviously, the first thing is going to be setting up the networking aspect of it. This is no different than any other VMware appliance that you might have deployed into. Because I'm deploying this in VMC, I'm actually going to be NATing this interface so I can actually reach it. So there'll be some configuration settings that I'll be accessing. There's the EC2 address. Oh, there we go. Just took a second. Okay. Just cancel this thing. So when it comes in here, there's a couple of sections. We've kind of reorganized the OVF properties just to kind of make it something simple. The first thing we're going to take a look at is basically the networking setting. No real surprise here. Since I'm deploying this in a VMC environment and I'm going to be exposing this via NATs, I'll need to enter an FQDN, but ideally this would be some FQDN that you would basically specify. In terms of the IP address, here we're going to specify our CIDR prefix. So basic network. And then if you have any kind of networking proxy, there's a section for proxy. So these are optional again. Next up is going to be your OS credential. So this is going to be the root password to your VEBA appliance. By default, we actually disable SSH. So if you need to get to the system for whatever reason, these are the credentials, and then you need to turn on SSH. Next up is going to be your vCenter endpoint. So in this case, we're going to be running this against VMC. This can be on-prem. So again, just any valid vCenter endpoint is all that we require.
And the port to be opened would just be the normal HTTPS port then to go against
Correct.
the API.
Yep. Yeah. So minimum requirement is just a read-only account, port 443 to vCenter. No other settings. So you don't need to make any actual changes to it. So very simple from a requirement standpoint. And then if you want to disable TLS, and then next up is you specify the processor. As you mentioned, we support 2 different processors. So depending on what you're trying to consume, if you're in VMC, there's a very high possibility you might want to interact with some of the native services in AWS or any cloud services for that matter, since you're running in the cloud. If you want to basically write your own functions in any particular language, you might choose OpenFast. So here in this deployment, we're going to choose OpenFast. Michael's actually going to take us through an event bridge scenario so you can kind of see how both work. But this will allow you to basically tell us which processor you're interested in, and we only deploy the configuration and ultimately the specific containers that are running in the appliance. So there are no additional containers that are running that aren't required. Next up, we're going to fill out our OpenFast configuration. So there's going to be a password basically protecting the UI endpoint as well as the API endpoint. So we'll go ahead and specify those right now. And then again, if you're deploying AWS Event Bridge, you go ahead and enable that. We also have a debugging section that allows you to have further customization. We'll just leave these off, but these are things that you can actually use to debug the system if you're having some issues. And then we'll go ahead and deploy.
I've ran into this with other appliances. I assume the pod CIDR network cannot be overlapping with the network you're actually using, right? So you should double check that as well.
Yep, that's correct. Yeah, so these networks are kind of the default from a Kubernetes standpoint, and there's really no way to protect it, right? Because there's so many different possible network combinations. So these settings are really allows you to basically customize it. So like Frank mentioned, if you're on a particular network that is the default for Kubernetes or Docker, for example, will allow you to basically tweak those, and then that will go into the deployment model. And the deployment is fairly quickly once you get it up and running. And I'll show you what it looks like once it's finished the importing. It takes a couple of minutes, and basically it sets up the Kubernetes infrastructure, takes in all the configurations you've provided it, and inserts them in the various places so that we have the system fully operational in a couple of minutes.
And with that, then one more question. You could configure one vCenter endpoint. So is it a one-to-one mapping to a single vCenter, or can you configure more than one vCenter in a single VEBA?
Yeah, that's a good question. So today we have a one-to-one mapping. The change that we introduced in our 0.3 or the latest update allows us in the future to be able to have multiple vCenter sources. There may be reasons why you might want to have a one-to-one mapping, maybe for a particular environment. Maybe this is a development environment, another environment's production. But in the future, we'll want to be able to support multiple event sources, so not just vCenter. NSX has traditionally been the more popular one that's come up after vCenter. But today we are limited to just one vCenter, but hopefully in the future, we'll be able to unlock that capability.
Okay, cool, thank you.
Okay, so we're almost done here. We'll go and power it up in a second. And then if you actually look into the console, you can actually get some progress in terms of what's happening. So you kind of have a feeling for where things are at. So we finished the deployment. So now we're just going to power it on. So you can see it's already starting the customization. So this is where it's taken in the root password that you provided, any kind of network configuration, and goes in and sets everything up there. Once that's completed, it's going to set up the single node Kubernetes cluster. And then it's going to start up all the required containers. And we actually pre-download a lot of the images. And so you can actually run this behind your corporate firewall. So I know that there are some questions early on is, do I need the internet to use this? The answer is no. Obviously, if you're going to rely on containers that might be publicly hosted, you probably need to download that and have that running in your own private registry, such as Harbor or something like that. But there are no requirements to basically go out to the internet. But if you are using some cloud services like Slack, like PagerDuty, you certainly will need a way to basically go out to the internet. And that's what the network proxy settings are there for if you need it.
Have you tested this with vSphere HA as well? Especially
in terms of?
That the internal Kubernetes comes up correctly and then restarts all the pods appropriately? Or is there anything you need to take care of manually after? I've seen both ways with Kubernetes. Yeah.
Yeah, no, that's the nice thing about Kubernetes. I mean, today it is still a single node deployment. So the manifests themselves will ensure that, hey, these containers are up and running unless something happens specifically. That's done for you automatically. And so you can issue reboots and the system will go ahead and automatically recover. Okay, so now that we've got this deployment, one of the things that we can actually do is actually go check on the endpoint. So if you come over and just open up a new tab, usually takes about a second or so. So we can actually even log in to take a look so I can kind of show you the inside. So these are the different containers. You can see here that we have various namespaces, right? So we have the VMware namespace that will basically run the event router. We have Project Contour, and obviously we specified an OpenFast processor, so you can see that's up and running. So now all the containers are operational. So if we go back to this endpoint, we'll now get this. Obviously, we don't have a valid certificate, but if we did, and we also have documentation now on how to actually bring your own TLS certificate. And so for customers that actually want to have that endpoint secured using your own valid certs, you can certainly do that and affect the change. And so this is the actual interface when you come into the system, right? So we have OpenFast, we've got nothing deployed, and I'm going to walk you through a very basic workflow where we're going to basically take a VM and we're going to power it on, and we want to capture that powered on event. And I actually want to automatically apply a vSphere tag. So before we get into that particular demo, we need to set up some things or have something set up here. So we'll go ahead and create a new tag category. Let's call this events, and we'll go ahead and apply that to just our VMs. And then here, I'll go ahead and create a tag. Let's call this vBrownBag. And one of the things that we're going to need in a second is going to be this ID. And this is specifically for the sample that we're running. So it really depends on how the function itself is being triggered. So if we come into our configuration file, earlier we talked about this YAML file. So let me make sure that this is enlarged enough so you guys can see it. Are you guys able to see that okay?
Yeah, that looks fine.
Yep.
Okay, cool. So again, here you specify the endpoint. Here I'm just running this on VMware Cloud and AWS, so I'm gonna have a public endpoint. And as an end user, all you really need to worry about is just really this one single line if you're a function consumer, right? So there's really two classes of folks, somebody that may write their own code, but you can certainly just consume what's been out there, and a lot of the samples that are really quite popular for a number of the basic use cases. So here, the scenario is I just want to apply a vSphere tag, and this happens to be in Python. We actually do have a sample using Power CLI, and you can actually create other samples. But if you're just wanting to use a function, all you need to do is specify your endpoint for VEBA and specify the events, right? There's no code that you need to write to say, how do I connect to this vCenter? How do I write the appropriate API for the event manager, query through the system, have that information then sent out to another system to process your results, right? And that's really the power of VEBA, is that we want to abstract away a lot of those details and make it as easy as like, you just tell us the event that you want, right? And this is the ID that shows up in vCenter, which is also available in that GitHub repo that I mentioned to you, right? So if you wanted to trigger on an HA event, you go look for the HA respective topic, right? It can be VM created, VM deleted. We have so many different examples, right? But literally it's just specifying this, and it's comma separated. So I can actually have a bunch of other events all triggering off this particular function, right? And this right here tells me what function I'm actually calling into. Now, for each of these functions, there's going to be some type of credentials that you're going to pass in. Here, because this function is going to affect this VM, we actually want to make some changes to the VM in terms of tagging. So there's going to be this external file that gets read in. This is a secrets file. Eventually, it turns into a Kubernetes secret, right? So here, I'm passing in my vCenter server. This is actually running internally to the network, so it's actually talking to the private IP of my vCenter. Earlier, you saw me create that tag. So I'm just going to copy and paste that, and then this is an attach operation. All of this is actually defined by the person who wrote the function, right? So I could have been actually a lot nicer, and instead of asking for this crazy long ID, I could have just said, give me the tag name, right? And when this gets passed into the function itself, it's going to go do the lookup itself, right? But just in this particular example, it's just using the raw ID for speed and purposes. Okay, so now that I got all of that going, we also want to set our endpoint. So this is actually where I'm going to go ahead and deploy my particular function. And so here we're going to be using the CLI called the fast CLI. And one of the first things you're going to want to do is basically log into their API endpoint. This is no different. Sorry. There we go. This is no different than me logging into the UI. And so you'll see this for a second. Okay, so now the credentials have been saved. And you can see earlier, I mentioned I had this config file, right? So here, this next line right here is going to create the VC config file. And this right here basically acts as a Kubernetes secret that's going to be right into my function. So I can securely pass in any kind of credentials, maybe some tokens. If I'm working with Slack, there may be some things I don't want to be in plain text. This is how you get to define that. And this file format can be any format. This happens to be a TOMO file. This can be JSON. This can be CSV. It can be an Excel doc if you want, right? Ultimately, the important thing is how this gets read in by your function specifically. Oops. Oh, yeah, it might help it to actually be inside the directory. Okay, so we've got a 202 here. And then all we're doing left is basically deploying our stack.yaml, right? So this is the exact same file that I just showed you, and we're just saying go ahead and deploy it. And now we get a 202 accepted, right? So now OpenFast has taken that function that we're consuming, right? I didn't have to write any lines of code. I'm just using a function that's been pre-created. And if we actually head back over to our portal, we can see that the function has been deployed. We can see that the status is now ready. And pay attention to the invocation, right? This has not been executed at all yet. So I come in, if I take a look at this VM, just happen to have a VM here. Let me refresh. Like I said, one of the most popular demos is actually auditing and security aspect of it. You know, given the amount of changes that happen in infrastructure and not realizing how destructive they can be. And we've seen a lot of cases where environments are getting hacked and you're not even aware of it, or changes are being made without you being knowing about it, right? And so one of the really popular one is just VM reconfiguration. Something that's really not, well known to a lot of people is that every change to a VM, we actually capture that delta. So for every change that you make, we have a specific event for that VM. And we tell you specifically what was changed. And so if somebody goes in and modifies a VM, adds some CPU, adds a memory, maybe adds an additional disk that it wasn't there supposed to be with, we actually capture the information. And so one popular use case that we've seen is that customers are able to pick up specific events that they care about. Maybe users get deleted, maybe a VM gets deleted, maybe a VM gets changed, maybe a host configuration, and they can cherry pick those things and have that forwarded off to a dedicated data warehouse, right, for auditing purposes. I used to work for a very large enterprise where we had to keep 2 years worth of audited information. And as you know, if you keep 2 years worth of information in vCenter, that becomes a very big database, right? And ultimately, I only care about a couple of those specific things that I already captured in the event payload. So using somebody like VEBA, I can actually take that out, send it to a specific external database, and I can actually do offline viewing, provide access to that, and not providing direct access to vCenter anymore, just like Michael mentioned. So we have the VM powered off, and here we can see that I already executed. So there's one invocation, right? And so so now if we go ahead and power on the VM gets powered on, we refresh it. Here we can see the event immediately gets kicked off. So you can imagine it took me longer to refresh the UI to show you the state of the system than this execution happening, right? And this is happening asynchronously to the system. And you can see here it's invocation count is 2. So you're going to ensure that changes in the infrastructure, you no longer have to manually audit. You don't need to make sure that you have processes in place to make sure that people follow particular directions, right? This can happen transparently behind the scenes for you. And this is really the power of event-driven automation and really focusing your efforts on the thing that you want to happen, right? That function is really, all it did was basically apply a tag. It didn't care about how I got that VM, what should I apply, right? That is provided out of the band. And that's really the power of VEBA when you start to look at it.
So, can everyone see my screen?
Yes.
Yep, you're good.
Yep. Okay. So what we see here is that we also deployed EventBridge as a second appliance. And I could also already see events coming in. So this one works. And you might ask, what is EventBridge? And so PK in the beginning mentioned this, that there might be cases, and we've seen these use cases and requirements where you either run close to AWS, like on VMC, or you have a specific need to integrate with AWS and be just forwarding logs into, like, from vCenter into AWS CloudWatch. And so instead of, which we had, like, there was this workaround before, you would write an OpenFast function and then it would just forward. We thought about, what about having a native integration? Instead of writing your function, you would just basically natively integrate into AWS. And so AWS has launched last year, they launched AWS or Amazon EventBridge, which is similar to VEBA. I wouldn't directly compare it, but conceptually it's similar in terms of there are sources, there's the EventBridge service, and then there's destinations, how they call it. And so sources can be AWS services like EC2, SQS, what have you. Can be other SaaS applications which companies, partners might provide, or could be custom apps. And so in our case, VEBA is a custom app that injects and forwards events into EventBridge. And then EventBridge itself is like a very sophisticated event processor with filtering, logic, and highly scalable, offered by AWS. And if you want to play with it, it's free for, I think, 1 million event invocations. So, like, there's likely you're not going to hit that with your personal account. And then you have some rules which match on specific events that you can configure, or fields in those events, which I'm going to show in a bit. And then these rules also define where the event will be sent into AWS. Most popular, obviously, Lambda, their function service, or notification services like SNS, etc. There's a lot of targets that are supported on EventBridge, and more are coming. So we expect that AWS EventBridge will be like most of our customers, joint customers, will use EventBridge for their own processing logic, and will have this requirement of uniting both worlds, like the vSphere or VMC environments with the AWS environments from different teams. So having said that on EventBridge, you've seen the deployment for OpenFast. EventBridge is just another processor which you fill in the configuration options, and it's detailed on the VEBA website, the GitHub repo, which we share at the end of the session. In EventBridge, you configure your event bus. You can have multiple of these event buses, and then essentially what you have is a rule And the rule is associated with a pattern. Pattern is nothing but a match on incoming events, and then it tells the EventBridge bus where or if to forward these events. Now, how does VEBA know which events to send to EventBridge? Because we don't want to send all the events to EventBridge, because that would be maybe like a lot of bandwidth, but also cost associated with it. So in case of VEBA, we've taken this approach of you configure an event pattern and in AWS on your EventBridge instance. And it follows this structure of the incoming payload. And when I show you a payload, you basically see that there's a subject field in there. And we use the subject field to identify the event type. So that could be, for example, DRS VM powered on event. Now, this is an array, a JSON array here in the event pattern on AWS. So you can specify multiple of these events. You can specify matches, like it starts with, or it ends with, or it's greater than, less than. So there's a lot of filtering logic that you can put in these event patterns here. But the VEBA appliance will use these patterns, or this pattern here, to understand which event it needs to forward to EventBridge. So everything that matches to these 4 types, VEBA will forward. If there's another event like user login session event, in this case, it would not be forwarded to EventBridge to not occur any cost and bandwidth. Okay, so how does it look like at the end of the day? So here I show a VM configured or reconfigured event. So I have set up my rule, this rule here, with one target. You can have multiple targets, which is like the fan out that PK described in the beginning, where I'm sending all the incoming events matching to one of these subjects or event types to CloudWatch. It's just a log forwarder, if you will. And this is the incoming structure in CloudWatch, how the event from VEBA, like from vCenter over VEBA to EventBridge, and then to CloudWatch looks like. You see a detail field here. You see a subject field here, and that's how the EventBridge pattern matched. So it matched on this VM reconfigured event. And then you see the whole data that vCenter sent us. That is all here in data. You see the key of this event, which user triggered it, which data sender, etc. And then you see full formatted message. You can even see what has changed. So I attached a disk in this case. It's a lot of data that and payload that is sent. You can literally match on any of these fields and values that are in there. And then there's kind of a summary here, config changes like modified, added, and deleted. And the beauty of this is this can be used for auditing. Like we've seen use cases where people just want to audit vMotions, migration events, or in this case, reconfigure changes events where they say maybe CPU has been added or memory has been added. You want to log that to as an email or as a Slack notification, or you want to revert that, like in Kubernetes, where Kubernetes sees if the desired state does not match the current state, it will just reset it. So you could write a function that just reverts this. And if you want to go further, something that we are currently exploring is putting this, or like extracting these messages here into something like text-to-speech, where like all the cloud providers offer this already. And so you would submit the string or any of the fields that you're interested in these events and forward it to any of these text-to-speech services. I just need to check whether I have share computer sound on. Let's see if this works.
VEBA OpenFA on 10.2.32.4 in SDDC data center is powered off.
Hopefully that, like, could you hear that? Did it come through?
Yes.
Yeah.
Okay, cool.
Just fine.
So this is just an example here, right? This, I mean, I copied it in here and I played it here because I don't have my home set up here, my Google Voice Assistant. But you could literally go that far and say like, okay, I've got a monitoring setup where people are notified for critical events on Slack, on email, on Voice Assistant, but I'm also on mobile if there's nobody in the room because everyone is at home. So the sky's the limit with these functions, be it using OpenFAS or EventBridge. And I think VEBA is a good setup, or is set up well for these different use cases. Looking at the time, I'm going to stop here and give it back to PK and Frank.
All right. So I guess what? Yeah, I just want to end with some closing. This says, you know, there are a lot of possibilities that are available, and yeah, it's truly endless. The question is, how are you planning on using VEBA? And you can absolutely reach us on. Sorry. You can reach us on different channels. We're available on vmwarecode.slack.com at the channel vCenter Event-broker-appliance. Join the community in discussing VEBA. And you can reach us. If you have ideas, tweet at us. Our handles are provided here. And if you have any feedback, feel free to email us at dl-veba@vmware.com. And our repository is located under the VMware samples location. And if you see any issues, definitely feel free to open issues under the GitHub repositories.
Yeah. Just one more question. William mentioned some example functions and some example code to be available. I would assume that is on the GitHub page as well?
Yep.
Yeah, if you go into the GitHub, there's an examples directory, and you'll see different languages broken down by the different use cases. And so there's a lot of just ones that are out of the box that you can just consume, like I mentioned. Like the tag example that I actually just figured out why it didn't work. So if we still have some time, happy to show that to you guys. But if not, you can take a look at this example function section here, and then there's some instructions on how to use each of these.
Mm-hmm.
Yeah, so I'm quickly showing you guys where to find the examples. It's under our GitHub repository, is organized by the languages that they're written under. And all the documentation on what it does and how to deploy those are under those example functions. And then I wanted to thank you guys again for your time. And if you like our initiative, support us and start the project on GitHub. And I'll turn it over to Frankie, and we can take a look at William's demo if we want.
Yeah, so don't only start the project on GitHub, right? Actually use it. That's far more important, I think.
Yep.
If you've identified a use case, feel free to download it. I'm going to personally use it in a couple of projects that I'm having, simply because certain APIs are not very easy to consume or can't monitor everything if you have a CMP running on top of vSphere. So this is where I personally see a very, very nice use case for VEBA in my own projects, actually.
So again, we really would like for you guys to take a look at it, give it a try in your home lab environment. Let us know if there are some particular use cases that aren't covered. We have PK from the product management team that's really interested in kind of hearing feedback and seeing how you might like to see this evolve over time, whether that's an appliance, multiple vCenter support, maybe NSX support, maybe a native Kubernetes offering. All these things we're definitely open to. So really appreciate your guys' time.
Yeah, and it's especially important that one thing you mentioned, this can trigger on VM deletions, right? Because alarms do not. If the object doesn't exist anymore, you cannot alarm on an object in vCenter. And that question comes up every couple of weeks in GSS tech support as well. I want to alarm on a deleted VM. So finally, we have a solution. I think we'll do one last shameless plug, because this is not the only appliance that you've built, William, right? Do you just quickly want to share the other appliance that you've built?
Yeah, sure. So this other project, let me see if I can pull up first, is something that we've been, given the situation at hand today, where we're at as a world, there are some things that, VMware and many other organizations out there is trying to help with. And so one of the things that I've been fortunate to be part of amongst other folks at VMware is folding at home. And this is like a distributed protein folding effort. It's been around for probably several decades now. And I came up with the idea amongst with other folks to be able to help, with the COVID-19 and in fact, other diseases. And so we put together this virtual appliance. It's 270 megabytes, so super tiny. It actually has the folding at home software. It's pre-installed. It's a virtual appliance. You can easily import into your vSphere environment, can run in a workstation or Fusion. And if you have some available CPU capacity, it's very CPU intensive. That's really where it uses its resources from. Feel free to join Team VMware. Our ID is 52737. It's actually encoded in the appliance. But if you wanted to support other causes, if you want to join other teams that are available, you can certainly do that. But we recently released this as a fling to help kind of with the efforts. And we've had over 300 plus folks contribute over the weekend. I think we've had like 1,500 downloads, which is probably the largest amount of downloads in just a couple of days of releasing the fling. And we're constantly making updates to the effort. And so if you want to help fight some viruses and all that, feel free to download this fling, but this is free for use. And really thanks for your support.
Thanks you guys for presenting today. It was a lot of fun. I learned quite a bit, and I hope the audience also learned quite a bit.
Yeah, thanks for everyone's time.
Thank you very much.
And those feedbacks.
Yeah, with that, we'll close the webinar. We'll look forward on hosting a couple more vBrownBags on a CNA topic in the coming future. So I'll tweet out those sessions once we have them available. Have a good night and good afternoon, everybody.